Hello and welcome to the flipped instructional recording for 1.08 Kinetic Energy. As we go through the lesson today, if you struggle with note taking, listen for the parts of the lesson that I tell you to add to your notes page. I will be covering the guiding questions, so be sure to jot down those answers. Also, don't forget to create a slide or a page or update your document for your notebook each time you work through a lesson. So as we jump into kinetic energy, look at our lesson introduction. Have you ever described something that moves quickly as having a lot of energy? In fact, scientists describe the movement of objects in terms of a specific type of energy called kinetic energy. You've already learned that energy is the ability to do work, and there are many different forms of energy. In this lesson, you will explore kinetic energy and learn how it relates to moving objects, how it can change, and how it can be calculated. So there is a graphic organizer here. I do encourage you to put it into your notes. It's good to fill it out by hand. Just challenges your brain a little bit, also helps with memorization, but it does go through, and it is a really good tool to use to look back and understand kinetic energy. So it would be a great thing to add to your notes. So there are lots of vocabulary words in our lesson today. Amplitude, arm, bob, energy, joule, and period. Remember, you don't just want to list the words, you actually want the definitions in your notes as well. And we have 8 guiding questions that we'll be going through as we read through the lesson. So I'm going to grab a screenshot really quickly so that I make sure we answer all of those as we go. All right. And so the first one we're looking at is, what is kinetic energy and what does it do? So here we go. Motion is energy. Kinetic energy is the energy an object has while it is in motion. So that answers guiding question 1. All moving objects have kinetic energy. Kinetic energy enables moving objects to perform work on other objects. So for the second part of the guiding question, what does it do? There's your answer. Enables moving objects to perform work on other objects. And remember, you can pause the recording anytime you need to if you're jotting down answers. So the bowling ball in this image has kinetic energy as it moves down the alley. The energy enables the bowling ball to do work on the pins and knock them over. Objects have kinetic energy while they are in motion. When the bowling ball stops moving, its kinetic energy is 0. However, there are many different forms of energy. An object at rest does not have kinetic energy, but it can have other kinds of energy. Kinetic energy depends on the mass. So the amount of kinetic energy, and we refer to that as KE, so you can abbreviate that in your notes too, of a moving object depends on its mass. And that's an important sentence. I would bullet point that in your notes. Suppose that while you're at a carnival, you decide to play a game that involves throwing a ball at a pyramid of 10 cans to knock them over. Imagine that on the first try, you throw a ping pong ball at the cans, and on the second try, you throw a baseball at the same speed. Which ball would have a greater impact on the cans, right? So if we look at the video, you can see a little ping pong ball. It doesn't weigh hardly anything. It just probably would bounce off. But we know a baseball, it's much heavier. We throw that at the same speed, it's going to have much more of an impact. So a baseball has a greater mass than a ping pong ball, which means it will have greater kinetic energy. This means the baseball will have a greater impact on the cans than the less massive ping pong ball. The baseball has a greater mass than the ping pong ball, which means it will have a greater kinetic energy. This means the baseball will have a greater impact on the cans and less massive than the less massive ping pong ball. That seemed like a very repetitive sentence. All right, so as we go on, Kinetic energy describes or depends on speed. So you've just learned that kinetic energy depends on mass, but in addition, the kinetic energy of a moving object also depends on how fast the object is moving. So you want another bullet point, and I would add this sentence in. So kinetic energy also depends on speed. Think about the carnival game when the pyramid of tin cans, with the pyramid of tin cans, and this time imagine that your dad steps up to try the game too. You both throw a ping pong ball at the tin cans, but your dad throws the baseball much faster than you do. So whose ball will have the greatest kinetic energy when it strikes the can? Watch this animation to see what happens in this scenario. Okay, so both of you throwing a ping pong ball. So maybe your dad throws much harder and the ping pong ball is able to knock over some of those tin cans. So the ball your dad threw had a greater speed, therefore greater kinetic energy than the ball that you threw. Okay, so this little note here says convert chemical energy. When you throw a ball, the muscles in your arms convert chemical energy in your body into mechanical energy that allows you to do work on the ball and set it in motion. Once the ball is in motion, chemical energy has been transformed to kinetic energy. Remember that when the ball is thrown, no energy is created or destroyed. It changes its form, but the total amount of energy is conserved. So kind of like when we learned about the conservation of mass, and we were balancing equations back in semester 8. This is the same concept, right? We are not creating or destroying energy. We are converting it. All right, so comparing kinetic energies. Let me make sure I kind of got off track with the guiding questions. I got distracted. 2 things that kinetic energy depend on and why. So if we go back, remember they depend on speed and kinetic energy depends on mass. And so if we were answering why, we can look in here and just know that the heavier the object, the greater, or the more mass the object has, the greater impact it will have. So that's why. And then for speed, it says the faster it's going, the greater the kinetic energy it will have. So that's the why. And then how do you calculate kinetic energy? We have not read that yet. So that is guiding question number 3. And so we're comparing the different kinetic energies. So it depends on mass and speed. So if you look at the 2 compact cars, the cars have a similar mass, but the first car is moving slowly through a maze of road intersections. The second car is moving down an open highway at a high rate of speed. Which car do you think has more kinetic energy? Okay, so if we're comparing those, one's going faster. If it's got more speed, it has more kinetic energy. So now compare the kinetic energy of the second compact car to the kinetic energy of the truck. Okay, remember mass is a factor as well. So both are traveling down an open highway at a high rate of speed. Which vehicle has the most kinetic energy? So if both compact car and the truck were traveling at the same rate of speed, right, the same speed, and they had to make an emergency stop using the same kind of brake system, which vehicle would have a greater stopping distance? So obviously it would take this big truck longer to stop. They would have a greater stopping distance because they have more mass. So if we look at this, 1, the car speeding down the open highway has more kinetic energy because it's moving at a faster rate of speed. 2, the truck has more kinetic energy than the compact car because it has more mass. And finally, the truck would have a greater stopping distance because it is more massive and has more kinetic energy. All right, so here's the equation, and you definitely need to have this in your notes And this is where I encourage you to take some notes too on sample problems, because you will be working through some of the potential and kinetic energy math problems. So you want to understand this equation. So number 3 says, how do you calculate kinetic energy? Here's the formula. Kinetic energy is a moving object, depends on both its mass and speed. And so this is the relationship. We're representing it here in the formula. Kinetic energy is equal to half the mass times the velocity squared. Okay, so I would write out this whole thing so that you know what everything means, mass and velocity. So in this equation, m is used to represent mass, which is in kilograms, and the symbol v is used to represent velocity, which, if you remember, is meters per second. So in this equation for kinetic energy, direction is not a factor. Therefore, velocity or speed can be plugged in for v. So you'll see those words interchanged. We're not talking about direction this time. You can use this equation to determine the kinetic energy of moving objects. So I would take a screenshot of this or write down this equation and have it in your notes. So to calculate, let's put this problem in your notes. A marble has a mass of 0.05 kilograms. You shoot it out of your hand and send it moving at a speed of 2 meters per second. How much kinetic energy does the marble have? Here are the steps to solve for kinetic energy. So you're going to square the quantity for speed. You only square this number. You don't multiply the 2 and square it. So you're only squaring the quantity for speed. You take 1/2 of the mass. Okay, so these are separate. You've got to remember your order of operations. You're taking only 1/2 of the mass, and then you multiply that number. So 1/2 of 0.05 is 0.25. 2 squared is 4. Okay, so it's not 2 times 2. When you square something, you're multiplying it times itself. So make sure you know it's not a multiplying by 2. So 2 times itself, 2, is 4 meters per second squared. So when you multiply those two numbers, you get 0.1, and then this kilogram times meters per second squared, that little ratio is equal to 1 joule. So kinetic energy is represented in J, capital J, a joule. So that is how you solve the problem. So we're going to try another one. You've got a kinetic energy problem to solve on your own, so you want to put it in your notes. It says a 50-kilogram girl is playing soccer. She runs towards the ball at a speed of 7 meters per second. How much kinetic energy does she have as she runs? Calculate the answer to this problem using the equation that we just saw. Okay, so you've got to be able, I have to grab a pencil so I can talk myself through it as well, to write out everything you know and what we're going to be doing with our problem here. So if we are talking about KE is going to equal 1/2, you've got 50, and then you've got 7 meters per second squared. So the first thing we did, and I can show you in this so you're able to see it, is you multiply 7 times itself. So that's 49. And then you half the 50. So it's 25 times 49, and that equals 1,225 joules. So the girl has 1,225 joules of kinetic energy as she runs towards the soccer ball. So that is the way you solve it. So why is kinetic energy important? So I'm looking through the guiding questions. We have the formula to calculate how much work does it take to stop an object with a lot of kinetic energy. So this is kind of where we'll get into that one. That's number 4. Sorry, my screen's popping up here. So work changes the energy of an object. So if an object, such as a truck, has a lot of kinetic energy, it takes a lot of work to stop it. Imagine that there are two trucks that are the same mass, they're 2,000 kilograms, and have the same braking force. Truck A is traveling at 20 meters per second, and truck B is traveling at 40 meters per second. How do you think their kinetic energies will compare? So if we were to plug those numbers in and solve the problem, we would be looking at a kinetic energy for the first truck to be 400,000 joules. And for the second truck, it would be 1,600,000 joules. All right, with just a difference of 20 meters per second. One was 20, one was 40. So you might think that the kinetic energy should be double because the speed is double, but it's actually 4 times bigger for truck B. And this means that it will take 4 times as much work to stop the truck. And here's the tricky part. It says the trucks both have the same braking force, meaning that truck B will need 4 times more distance to slow down and stop because it has so much more kinetic energy. So for question 4, how much work does it take to stop an object with a lot of kinetic energy? If we look through, it's going to take, this says 4 times the distance. So if you're multiplying and using that formula, it's saying it's taking 4 times the amount to stop. And so moving to question 5, when is kinetic energy the greatest in a ball you throw in the air? Okay, so we're going on to the next one, changes in kinetic energy. The kinetic energy of a moving object often changes. For some motions, you can predict when the kinetic energy will be least and when it will be the greatest. So imagine that you throw a ball straight up in the air. It moves quickly when you release it, but then it gradually slows down as it rises higher in the air. Once the ball reaches its highest point, it stops moving for a brief moment and then starts to fall back to you. As the ball falls, its kinetic energy increases until you catch it. So take a look at this animation. The kinetic energy of the ball is greatest at the beginning and the end of its flight. So that's right, after you throw it and right before you catch it. The kinetic energy is the least when the ball is at the highest point in the air, and then again when you catch it. So this may be something you want to draw out. It's very easy to draw if you had a hand and a ball, and you drew an arrow going up and then coming back down. So the kinetic energy is the highest at the bottom when you first toss it and at the bottom when you catch it. So it's the kinetic energy is the highest almost at your hand, and it's the lowest at its highest point in the air. So if we take a look at that, kind of gives you an idea. So you might want to draw that out, or you could write it out. But that answers question number 5. When is the kinetic energy the greatest in a ball that you throw in the air? It's when it leaves your hand and when you catch it. All right, and then question 6 says, what is a pendulum and what are its parts? So a pendulum is the brass or the wooden bar swinging back or forth in a grandfather clock. So something like this. Okay, a swing in a park is also a kind of pendulum. The key characteristic of a pendulum is that it moves back and forth at a constant amount of time. So that is your answer. What is a pendulum? So look at the images of everyday pendulums. What part do all pendulums have in common? So here are some pictures. The answer is one has a string and one a bar, but they're both attached to a fixed object, a tree or a clock. And something is attached to the bottom of the string or bar, like the ball, or it says a toy figure on the clock is attached to the bottom. So they both have a fixed object, they both have a bar or a string, and they both have an object at the end. Okay, so that answers number 6. When you move on, we saw that. here are the parts of a pendulum. I would draw this in your notes. So the pivot is the point where the pendulum is attached to a non-moving object. That's at the top. The bob is the mass that's attached at the bottom. And then the arm is like the string or the bar that attaches the bob to the pivot. And that's the length it's measured, right? So it's measured from the pivot to the center of the bob. So the arm length. So make sure you have that in your notes. You might take a screenshot or draw it out. So now you need to understand pendulum in motion. So there's some different things that happen here. So that's number 7. What's the difference between period and amplitude? So if you watch the pendulum in motion, right? So the person just pulls the string and lets it go. The period is the time it takes in seconds for the pendulum to complete a full swing. So that means it moves from one side to the other and back. So that's a period. The amplitude is the measure of the angle the pendulum swings from its original position. So this is the amplitude, the measure of that angle. The period is this distance, all the way there, the time it takes, I'm sorry, and all the way back. So make sure you know the difference in those two words. Kinetic energy of a pendulum. You can also predict when kinetic energy will be the greatest or the least for the motion of a pendulum. Imagine that you set a pendulum in motion. As the pendulum swings downward, it moves faster until it reaches its maximum speed at the bottom of the swing. As the pendulum swings upward, it slows down until it briefly stops moving at the top of the swing. The kinetic energy of the pendulum is greatest at the bottom of the swing and least at the tops of the swings. So if we play this, the bottom of the swing, you can see the kinetic energy is higher, and then as it starts to go up, it gets lower. If you look over here, you're able to see that kinetic energy going up and down. So kinetic energy increases as the pendulum swings downward and decreases as the pendulum swings upward. Okay, so that is the answer to question number 8. When is kinetic energy the greatest and the least? So that sentence will answer that question for you. So take a look at the animation. We did that. We watched the energy bar, and then you're able to see how much kinetic energy the pendulum has. All right. So the kinetic energy of a swing. Imagine that you're swinging on a swing set. Your motion is similar to the motion of the pendulum in the previous example. At what point or points of the swing is your kinetic energy the greatest? So you're looking at the little girl swinging, and kind of like the pendulum we saw earlier, the kinetic energy is the greatest at the lowest point or the bottom. And it's going to be the highest or the least, greatest at the low point, highest at the top of the swing. So the kinetic energy is the highest at the top of the swing. All right, and then finally, to review really quickly, these are 5 questions that you can work through to just test your ability to solve the problems, the math that we worked through, and just some of the questions on concepts that we worked through today. So make sure you go through all of those, check your answers. If you miss any of them, put them in your notes, because that will be something you'll see on the quiz or even the unit test. So all your guiding questions have been answered. And as we wrap up, look for the flip follow-up session in your Class Connect schedule. Attend Help Lab if you need any extra help, and have a great day.